is Laura and Adi, and this is our project warehouse. The project consists mainly in the optimization of a 9 SKUs warehouse by reducing the time between picking up an item and taking it to the shipping area. First, we've run our simulation only with one robot in it. For that, this is the launch file that will load both the warehouse map and the robot in RPs. And then, this is the Python script that will give the robot a moving command. In here, we first randomly selected a number of items to be shipped, and then this item's position is sent to the robot as waypoints, so it creates the shortest path to go and pick those orders, and once it has all of them, taken to the shipping area all the orders. For running our simulation, we're going to need two terminals. In the first one, we're gonna load the launch file. As we can see, both the map and the robot at its initial position are loaded in RB. Secondly, the script with the moving commands will be run in another terminal. Here, we have all the selected items printed on the terminal window, and as can be seen, the robot has already designed the shortest path to go and pick the first item, and it's starting moving.
So as from the image you can see, this is our sample warehouse in which we have 18 SKUs. The pink part is the restocking area, the other part is the receiving area, and the greenish part is the shipping area. Further, we use this PNG file to create a world in the RVs, and then we loaded two robots. Here two robots can navigate throughout the world. The optimal order list is generated by the random function from Python, and our objective is to optimize the whole warehouse operation in the best way as possible. So before we get started, you need to download the Python's pandas library. So to download the package, you just need to write down this command line into the terminal, and it will download the pandas library to your Ubuntu machine. Now the next step is to copy our package from the GitHub to your Ubuntu machine. So to do so, you need to follow the next steps. So first open the terminal window, then just simply copy the following lines. Just copy them one by one, don't copy the two lines together. Now after doing the catkin create package, we'll have the multi-robot package in our catkin workspace. As you can see, we have successfully created the new package. It will also create the CMake list and package.xml. Further, you need to create the scripts, which can be done by these two lines. So now we have the scripts. Now the next step is to copy the package from the GitHub. So to do so, let's go to the downloads and then simply copy the link. This will ask for the ID password of your GitHub because our course is the private, so you need to enter the ID and password. So mine is Tilfy. So now it will download. As you can see, it is done. Now we can see that into the downloads, which is over here. Now once the full package is downloaded into the downloads, just go to downloads, then the project, multi-robot, and select everything and copy it to the package we created using the catkin make. Now you can see we have all the packages. Now the next step is to do the catkin make. So for that, open the new terminal, go to catkin workspace and do catkin make. It is processing and it is done. If you see any error, then you should check out the CMake list or package.xml, because maybe that's where you have something wrong and this is why the program is not able to do the catkin make. Now the next step is to execute all the Python scripts we have over here. To do so, just copy this command line and then do the chmod. Now every Python script is executed, and now we can use those Python script into the RVs or gazebo. So as we have everything ready, the next step is to go through the scripts that I have written. So in the first terminal, go to the multi-robot package and then run the selection.py. This will basically take the 15 orders randomly from the CSV file that we have, in which we have total number of 18 SKUs, and it will divide the job between two robots. So here we have written the command in such way that whichever the robot has the lower number of items to pick, the restocking and receiving part of the job will be provided to that particular robot. And now in the second terminal, launch the world that we have. This will open the world with the two robots inside the world. So here you can see that we have the map ready and the two robots in it. Now everything seems fine. We can further open the third terminal, and then we can do the run for the robot number 1. This will give the code to the robot 1, and now in the fourth terminal we need to do the run for the robot number 2. So as you can see, here are the orders that generated. The first job for robot 1 is to pick up the item R1, and for the robot number 2 it is L4. Here the operation is a little bit slow because Ubuntu machine doesn't recognize the NVIDIA graphic card that I have. Also, as you can see, the probability cloud, the point cloud for the robot's location is not as good as before, but it is able to follow the line, but also it is slow. So that was the first part. In the part 2, we have compared two robots. One is the low duty robot and the second one is the heavy duty robot. Here it is assumed that the low duty robot can pick only 3 items at a time, while the heavy duty robot can pick more than 13 items at a time. So the heavy duty robot will have to go to the shipping area in order to pick items to drop. It will be the last compared to the low duty robot. So to perform this task, in the terminal 1, we need to run the selection.py again. So raw cd and we have to do the raw sum for the selection.py. So here you can see these are the 15 orders generated randomly from the 18 SKUs, and job for robot 1 and robot 2 is provided. Because robot 2 has less items to pick, the receiving and restocking part is given to that particular robot. In the next video you will see the whole operation. So as shown in the previous video, you can see that the low duty robot had to go to the shipping area after picking some items, and it was time consuming. So now let's see the operation with the heavy duty robot, in which the robot can carry all the items and it has to go to the shipping area only one time at the end. So in the previous video it was the operation for the heavy duty robot. Now for the lower duty and the heavy duty we can perform the robot 2 using this guideline. The guideline for the both of the robots are given over here. After running 4 scripts, this table shows which robot performs better. So here we had only 18 SKUs, but in the real life scenario where we have more than 18 SKUs, we can see that heavy duty robot can perform better because only for the 18 SKUs the heavy duty robot was more efficient. So it is desirable to have the heavy duty robot in the warehouse operation to perform each task fast. So now jumping back to part 1 scenario in which we saw the 2 robot navigation, but it wasn't as clear because the Ubuntu machine was so slow. So now I'm going to show you the same operation but with only one launch file and one robot. So before we go further, we need to remove the remapping parts from the navigation file. It can be done by removing the robot 1 and robot 1 here. Now in the terminal window, open the single robot launch file. It will fire up the RVs. Now position that, and in the new terminal let's run the script we edited. So it will start navigating, but here you can see the robot 1 has lower number of items to pick, so the receiving and restocking part can be done by the robot 1. So in meantime, for the future scope of this project, we can have more than 18 SKUs to make it more realistic as the real world problem, and then we can add multiple robots, more than 2, and we can also improve the navigation part as because while we had 2 robots in the same map, the navigation wasn't as good as it is with the one robot. So that can be in the future scope, and we can have the real warehouse map, the realistic map in which we have more than 18 SKUs. And of course there is like always a chance to improve the navigation. So now the robot has picked all the items, it will go to shipping, and then it will go to the restocking and receiving. But here it is noticeable that it will go to the right hand side receiving area, because this part is for the robot 1 and this part is provided for the robot 2, and it will go over here and pick the items, and it will put it to the restocking area. Here the location was a little bit further because these lines are the walls for the robot, so if I have any point over here, the robot will not go there because it is identified as the wall. So in the future, while you are working in a project like that, you need to provide a point XY coordinates which is not on these lines, so it has to be out of this, like this area. Yeah, it just like started to do the same stuff. Right, so that was all about my project, and let me know if you have any questions in the comment box. Thank you so much for watching.